Welcome to the Scan to BIM for Increased Profit workshop. Let's introduce myself. My name is Gustavo Garcia. I'm a mechanical engineer with more than 20 years experience during designing plants. I have collaborated in many projects in the fields of water hammer or transient analysis in pipelines, pipe stress analysis and pressure vessel, as well as heat exchanger designs. 10 years ago, I was collaborating in a revamping project for an old plant, and we realized that the customer hadn't updated since years the plant information. This is a common case in 80% of the plants. That was the reason why I started to work with 3D laser scan. By that time, you can figure out that the information that you could find through internet was poor. So, as a first step, we asked for technical information to many 3D scans manufacturers. Obviously, each one explained us the benefits of their scanners. In the end, we had to explore ourselves the best workflow and softwares in order to create the 3D as-built models that we needed for the scope of our project with accuracy and quality. In this workshop, I will try to explain from my point of view and experience the different workflows you can use for scan to BIM projects. The main objective of this workshop is to provide guidelines to improve the workflow to obtain 2D, 3D as-built models from the point clouds. The goal is to guarantee the accuracy and reduce time and efforts. Our focus will be pointed on industrial facilities, but it can also be applied to buildings. Just for your information, here you can find the glossary of words that we will use in this presentation. In this slide, in the first chapter, we will talk about the common workflow that is used in 90% of scan to BIM projects. This workflow presents some issues that must be taken into account. Mainly, those arise when you have a high density of pipeline and structures in a big area. We will discuss in detail about that in the next slides. In the second chapter, I will share you some tips that may help in this kind of projects. After that, I will introduce an example and you will have to think if the typical workflow can help you or you need to improve a little bit more in this field. Finally, I will show different softwares you can find in the market and the related workflows you can follow in order to create as-built models with quality, accuracy, and besides all, save time and efforts. Nowadays, it's easy to find in internet information and some video tutorials explaining this workflow and their benefits. I want to point out that using this workflow you will be able to do 60 to 80% of jobs scan to BIM. For that reason, we assume that the workflow can be used to do this kind of scan to BIM works and as a base for future improvements. Under my point of view and common way to perform the job, I spread the schema in many important steps that you may want to take into account. The most important issue that conditions all the project is the scope area. If your scope area is small, you won't have important problems. But if your scope area is big, you have to take into account some key points. The first one that you have to ask yourself is how you will manage the point clouds. Easily, the weight of a point cloud is around 6 or 10 gigas or more. The second issue you have to think about is the methodology you will use for the registration of the multiple scans to obtain the unified point cloud. The methodology will conditionate the scans locations. The third item you have to think about is how you will divide the scope area in small parts. Surely you will need more than one unified point of clouds. That's why it's important to create an structured unified point clouds. Once the three mentioned items are decided, you need to log into your 3D piping software, like Plan 3D, Revit, CADWorks, SmartPlan, PDMS, or others, and attach into the file the unified point cloud as external reference. The result is that you have the cloud as a reference. By using the features that you have able in the 3D piping software, you have to do the manual extraction location of the pipelines of structures. In this picture, I show you an example in Plan 3D. For the manual extraction of the pipelines, I use the centerline feature. For the pipe supports and structure locations, I define different slide planes. As you can imagine, if you have a high density of pipelines in your scope area, it will take a lot of time and effort to create the 3D as-built model. In this project, it is important and helpful to visit in situ the area subject to the scope of work. During this visit, it is important to have in mind the planning of the scope of the work to be done. Depending on how the model will be used and the level of available information, you will fix the level of detail of the as-built model and the deliverables with the customer. Meanwhile, you can see the scan locations in order to prepare a scan plan and define the multiple scan methodology you will follow. The most frequent deliverables are the as-built model and the pipe specification used, layout drawings, isometrics, the structured unified point clouds, and other specific information related to the scope of work. Normally, the laser capture are performed by an external company. An important issue is in case you have to be present on the day the scans captures are made. Why is it important? Because you have to do a parallel work while the scans are done. You must have to agree with the external company some external survey reference. Also, you must check all the information that the customer delivered and take notes on the difference encountered. Also, you should take picture of all objects details you have to model and the scope area. I recommend take your time on that point. You will need it as a support while you are creating the 3D model in your office. That it will save time and efforts. Also, you have to do all the measurements of the objects for which you don't have information. For example, all beams, structural details, vessels, equipment, and constructor details. You have to keep in mind in the point clouds you will see some areas with shadows or pipeline routings discontinuous. These problems can be caused because environmental light, the types of surface, shadows between objects, or the location of the scanner. As I said a few minutes ago, usually the scans are taken by an external company. They have to take into account these aspects in order to minimize these issues. If you have doubts, my recommendation is to do some scans in different locations and see the results. Depending on that, you can adjust the resolution of the scans, reduce distance between scans, or modify the scan angle of incidence. At this stage, one of the most important items to take into account at the purpose of obtaining a good result in the unified point cloud is the scans methodology to apply. Remember that there is a strong relation between the geometry of the object to scan or the scene to scan with the methodology you have to apply. Surely, you will have to use external survey reference in combination with your overlapping scans and targeting. At the end of the scan process, you will have a singular point cloud and the relative position per each scan. Now, it's time to join all the singular cloud points obtained in a unified point cloud. This process is called registration process, where you use different methods: cloud to cloud, singular points, Targetos spheres, and the topographic prism. The cloud to cloud method requires a high overlapping between scans, and we recommend to use external references. The singular point method only requires finding common points between scans. If you use Targetos spheres, that requires finding a common, easily recognizable points in more than one scan. If you use topographic prism, we require points with the traditional topographic georeferencing, and the maximum distance between scans is 150 meters. We recommend to apply or to use the topographic prism when you have circular or spherical surface, like, for example, circular vessels or tanks. Nowadays, the use of drones is increasing because you can scan quickly big areas where it's difficult to access or out of reach. The drone scans can be added easily to the unified point cloud. In a previous slide, we saw what the registration process implies. I just want to point out that it's important to work with a structured unified point clouds. Remember, the unified point cloud has to be located in the project coordinates. In plans, it's important to know where is defined at the north of the plan, and sometimes there is a difference between the plan and the geographical north. This picture is an example of how we see a point cloud in recap. In recap, the bubbles visually shows you the different locations of the scan, and this has been adopted by other programs you can find on the market for the point cloud registration process. I want to show you here the most common scanner brands and registration software you can find in the market. Just to note that there is a correlation between laser scanner devices and the registration software. For instance, if you use a Faro scanner device, you must use Faro Sen for the registration process in order to avoid problems. Or if you use Leica scanner device, you must use Cyclone for the registration. Now, I propose you to think about the workflow we have to follow to obtain a 3D as-built model for the next example. This model will be used to plan a new revamp of the plan. The idea is from the 3D as-built model, the customer will update the isometrics of the existing lines and generate new isometrics of the new lines. You can see our scope area in the picture. The customer told me there are more than 300 pipelines and different types of them. There are heat-insulated pipelines, stainless steel pipelines, carbon steel, and Teflon pipelines. In this example, we have some issues to keep in mind. First one, the Teflon pipelines. It is well known that this kind of pipelines cannot be modified on the field. This is why we will have to guarantee the accuracy of the 3D model as built model. Second, for the heat-insulated pipelines, if they are old, we will have problems with the routing. Third, risk for the specular reflection during the scans for the stainless steel pipelines. I think we altogether arrive to the same conclusion. If we follow the workflow previously explained, it will take a lot of time and effort to create the 3D as-built model, and we won't be able to assure the model's accuracy, especially for the Teflon pipelines. So, we have to think how we can improve the work. A solution can be trying to find in the market a software that automates from the cloud point the object recognition and their extraction easily to the 3D as-built model. Other possible solution can be we follow the previous workflow to create the 3D as-built model. When we finish it, verify the quality and the accuracy of the model comparing the 3D model with the point cloud. I have great news because both solutions can be applied because there are two softwares in the market easily can help you. In both cases, we will have to improve the workflow. Edgewise is the tool that automates from the point cloud the object recognition and then easily can be exported to the 3D piping software. In order to increase the results obtained using Edgewise tools, we have to modify or improve our previous workflow doing registration process individually for each scan. Then, Edgewise will be able to create a point database from your scan data showing you a unified point cloud as a previous result. While the database is created, the recognition algorithms start to work recognizing automatically pipes, conduits, and ducts with accuracy. Also, this tool can recognize beams, walls, and grounds. Finally, we must apply a pipe specification in Edgewise before we export pipelines recognized to the 3D piping software. The final result is that all the routings of pipelines recognized are drawn automatically in your piping software model. Of course, using Edgewise, you will reduce in between 40–50% time and effort to create the 3D as-built model. At the same time, we assure the model precision. Another point that we have available in the market is the Verity tool. Verity verifies and compares the objects located in the point cloud with the 3D as-built model. It will help you to validate the quality of the 3D as-built model and to make sure it accurately conforms the point cloud. That's why we recommend to use Verity before generate the isometrics, layouts, etc. If the measures on field were taken using traditional methods, surely you will have errors in the locations of the pipes in your 3D model. The next picture shows you in purple color where is located the pipe in the 3D as-built model, and in blue color where it's supposed to be. As you can see, Verity is a powerful tool that helps you to assure the accuracy of your model before you generate more information, for instance, the isometrics and layouts. Verity is particularly valuable as a quality check on inexperienced modelers' outsourced modeling jobs. It works as a plugin for Navis Work Manage or Simulate and automatically checks the accuracy of the 3D as-built model from the point cloud, and also reports automatically the missing and out of tolerance objects. It also allows you to adjust the model into place against point cloud to create a true as-built model for reporting and clash detection. Verity really can help you when you have a lot of information measured on field by traditional measures, and it is important to assure the accuracy and the quality of the 3D as-built model. Thanks for your attention. It has been a pleasure to present this workshop to you. If you want to contact me, just send an email to gustau.garcia@catalonia.es.